What is analytics anyway? And why should builders care? Think of it as the science of making brilliant decisions, which, let's be honest, is pretty handy when you're trying to build a skyscraper or a massive bridge. Analytics is all about using advanced analytical methods, a bit of maths, a dash of statistics, and a whole lot of clever thinking to help improve decision-making. It's like having a super intelligent co-pilot for your entire project, constantly looking at all the variables, all the possibilities, and pointing you towards the best route. In the world of construction, where things can get incredibly complex incredibly quickly, having this kind of analytical power is frankly a game changer. Ultimately, analytics is about working smarter, not just harder. Section 2, the OR toolkit. More than just a spanner and a hammer. Now when we talk about analytics, we're not just talking about one single magic trick. Oh no, it's more like a well-stocked toolbox, absolutely brimming with clever techniques designed to tackle all sorts of challenges. Think of it as the Swiss Army knife for project managers and engineers. Some of the headline acts in this toolkit include optimization, forecasting, and simulation modeling. Optimization is a big one. It's all about finding the possible solution from a whole host of options, given certain constraints. For example, how do you allocate your limited supply of cranes to various tasks to minimize waiting times and maximize progress? Optimization algorithms can chew through the possibilities and spit out the most efficient plan. Then there's forecasting. Forecasting uses historical data and statistical models to make educated guesses about the future. In construction, this could mean predicting material price fluctuations, forecasting the demand for certain types of skilled labor, or even estimating project completion times with greater accuracy. And finally, we have simulation modeling. Section 3, laying the foundations, linear programming for resource juggling. Right, let's dive a bit deeper into one of those clever OR tools I mentioned, linear programming, or LP for those in the know. Linear programming is a mathematical technique used to achieve the best possible outcome, like maximum profit or minimum cost, in a given situation, especially when you're dealing with limited resources or constraints. In the world of construction, resources are everything. You've got materials like concrete, steel, and timber, you've got equipment like diggers, cranes, and trucks, and you've got your workforce, the skilled hands that put it all together. The challenge is that these resources are often limited and they all cost money. Linear programming is absolutely brilliant for resource allocation because it can take all these variables, the cost of materials, the availability of workers, the capacity of your equipment, and work out the most efficient way to distribute them across all the different tasks that need doing. Project scheduling is another area where LP really shines. A construction project is a complex dance of interconnected activities. LP can help create an optimal schedule that minimizes the overall project duration or cost, while respecting all these dependencies and resource limitations. It's all about making the most of what you've got. Section 4, keeping things moving, project scheduling and queuing theory, no more traffic jams on site. Now nobody likes a queue, do they? Whether it's for a morning coffee or waiting for a theme park ride, queues are frustrating. And on a construction site, queues can mean serious money down the drain. This is where another fascinating bit of analytics comes into play, queuing theory. It's literally the mathematical study of waiting lines, or queues. Queuing theory helps us understand how queues form, how long things, or people, are likely to wait, and how we can manage them more effectively. For workforce scheduling, this means figuring out the optimal number of workers for a particular task or area. Too few and you get a backlog, with expensive equipment sitting idle. Too many, and you've got people standing around, which is also a waste of resources. Queuing models can analyze arrival rates, how often tasks become available, and service rates, how quickly a crew can complete a task, to help strike that perfect balance, ensuring a smooth flow of work. The same principles apply brilliantly to equipment scheduling. It's about minimizing that costly idle time and maximizing the productivity of your most valuable assets. Section 5. Dodging disasters risk analysis with Monte Carlo, simulation and decision trees. Construction projects are, let's be honest, inherently risky beasts. You're battling the weather, unpredictable ground conditions, potential supply chain disruptions, labor shortages, design changes. The list of things that can go wrong is long and slightly terrifying. This is why robust risk analysis is absolutely crucial. And guess what? Analytics has some incredibly powerful tools to help us peer into the murky future and prepare for the worst, or at least understand the probabilities. Two of the big hitters here are Monte Carlo simulation and decision trees. Monte Carlo simulation is a particularly clever bit of kit. Named after the famous casino, it's all about understanding uncertainty by running many what-if scenarios. Instead of just guessing a single outcome for, say, material delivery times or the duration of a specific task, you define a range of possibilities and their likelihoods. The simulation then randomly picks values from these ranges thousands, even tens of thousands of times, and calculates the overall project outcome for each run. This gives you not just one predicted completion date or cost, but a whole probability distribution, showing you the chances of finishing by a certain date or staying within a particular budget. Section 6. Counting the pennies, accurately. A case study in OR-powered cost forecasting. The budget. The bane of many a construction manager's life. Getting cost forecasting right is fundamental to a project's success, yet it's notoriously difficult. Simple spreadsheets and guesses can only take you so far, especially with large, complex projects. Or techniques offer sophisticated and reliable ways to predict and control costs. Or methods bring rigor to cost forecasting. Techniques like regression analysis use historical data to identify cost relationships. Simulation, like Monte Carlo methods, models cost variability to generate a range of possible costs. Section 7. The future is now, almost AI, smart cities, and construction's next big leap. The construction industry, sometimes seen as a bit traditional, a bit slow to embrace the cutting edge, is actually on the cusp of some truly revolutionary changes. And, you guessed it, analytics is right there in the thick of it, helping to make sense of and integrate these exciting new developments. We're talking about things like artificial intelligence, AI, driving automation on site, and the rise of smart cities, which are going to need incredibly sophisticated planning and management. These aren't just futuristic fantasies, they're trends that are gathering pace, and OR provides the intellectual horsepower to make them a reality. AI-driven construction automation is a particularly thrilling prospect. Imagine robots meticulously laying bricks with superhuman precision and speed, or autonomous drones constantly surveying the site, feeding data back to an AI that adjusts schedules and resource allocations in real time. Section 8. Building bigger, smarter, faster AI optimization for megaprojects. Megaprojects like high-speed rail networks, suspension bridges, and new city districts are incredibly complex. Traditional project management can be overwhelmed. AI-powered optimization excels here, taming immense complexity. Machine learning analyzes colossal datasets and historical data, identifying patterns, predicting bottlenecks, and suggesting optimal solutions. For example, optimizing pipeline routes considering environmental and cost factors. It's like having 1,000 analysts. AI revolutionizes infrastructure from design to maintenance. Section 9, wrapping it up, the unstoppable rise of OR in construction. So, there we have it. Analytics. It might sound like something cooked up in a university laboratory, far removed from the mud and grit of a construction site, but as we've seen, it's anything but. It's a collection of incredibly powerful, practical tools that are helping to revolutionize the way we plan, build, and manage everything from a modest extension to a sprawling new city. The core benefits are clear as day: massively improved efficiency, significant cost effectiveness, much smarter workforce and equipment management, and a far better handle on those pesky risks that can derail even the best laid plans. It's crucial to remember that OR isn't just for the academics or the data scientists locked away in an office. Its principles and techniques can and should be understood and utilized by construction managers, industrial engineers, and project planners out in the field. Whether it's using linear programming to get your resource allocation spot on, applying queuing theory to stop those site traffic jams, or employing Monte Carlo simulations to see what troubles might be lurking around the corner, Oregon offers tangible solutions to real-world construction challenges. It's about making informed, data-driven decisions rather than relying on guesswork or outdated habits.